Okay, so now we're going to continue our last lesson with another example. This will be example 2. Now, the main difference between this example is that it's slightly harder, but not really. It just takes a few more extra steps. But we'll realize that the extra steps are actually just basically the same procedure once again. So in this case, instead of a linear formula, we have a quadratic expression all over a linear expression. You have x squared minus 9x plus 20 all over x minus 5. The same process. Make the start of the long division diagram, these two lines, and you put x squared minus 9x plus 20 on the right side and x minus 5 on the left side. So those are there. Take the first term, x squared, and divide it by x, and you get x, and you put that x on the top of the right side, and then you take that x and you multiply it by x minus 5. So x times x minus 5 is x squared minus 5x. And you put that under x squared minus 9x plus 20. Make sure, and this is very important, that the powers of your terms match in the places you're putting them. So if you have x squared, anything to the power of 2, you put it under anything else to the power of 2. You have x squared, under it you have x squared. You have 9x, under it you have 5x because it's to the power of 1. You don't have anything at x to the power of 0, which would be equal to 1, and so there's no x. So you don't put anything under 20. So now we have to cancel out things. So in this case, we're going to cancel out x squared, and since they're both positive, we do that with a minus sign. X squared minus x squared, nothing. Minus 9x minus 5x. Two minuses make a plus, so it's minus 9x plus 5x. You have minus 4x plus 20. Okay. And in this case, last time, this is where we stopped. But because now we ended up with a linear expression from a quadratic expression, you'll notice that we're going down in terms of powers. And remember, we only stop when the power of the original denominator is greater than the power of the remainder produced. And in this case, it's equal to, not greater than. So we have to do negative 4x divided by x again, and in that case, we would get minus 4. Put the minus 4 on top with the x. So in this case, now our quotient is x minus 4. But we're not going to multiply x minus 4 by x minus 5. In this case, we're only multiplying minus 4 by x minus 5. So always take the term produced in turn with the original denominator you have to multiply it by. So when we got x, we times x by x minus 5. When we got minus 4, we times that only with x minus 5. We're not doing x minus 4 times x minus 5. We're doing minus 4 times x minus 5. Always take the singular term produced during that division. So minus 4 times x minus 5, we have minus 4x plus 20. Because minus 4 times minus 5, minus minus make plus, so it's 20. In this case, we have something special. Now we can cancel both terms with just a minus. Minus 4x minus minus 4x, that's minus 4x plus 4x, it's 0. 20 minus 20 is 0. And this will be interesting. So we have our quotient x minus 4 and the remainder 0. Therefore, the answer will be x minus 4. But remember, last lesson I told you that the general formula for deducing the answer to the division of a polynomial would be the quotient plus the remainder all over the original denominator. Now that's interesting, because here our remainder is 0. And if we were to do x minus 4 plus 0 on x minus 5, that would just be 0. So x minus 4. Therefore, when we come to this unique situation where you have the remainder as 0, we can take note of this following important detail, that whenever the remainder comes out as 0, the answer should only contain the complete quotient. And so if the remainder is 0, you omit it from your answer entirely. And with that, I think we've learned something quite good in terms of dividing polynomials. The next lesson will tackle a harder example about this certain topic. However, we'll soon conclude this and move on to another section in introductory algebra.